Okay, so I've already reminded you about it once, but I'll remind you again, vector assignments due tomorrow. Make sure you bring it to class. I will accept it at the start of class tomorrow. Okay, don't try and get it here for 8:30. Right, just bring it to the start of class and I will take them then. If anybody wants to hand them in early, I'm happy to take them off your hands now if you want to. Plan is this. We're going to do more projectile stuff today, and then we're going to do the unit exam review tomorrow. Okay, we have a short class tomorrow, so it's a good opportunity to do the unit exam review because it doesn't take a full class. All right, so I will give you some information about the exam itself. Okay, and as I said before, the review package will post on Google Classroom at 3:20 today, so you can have access to that and check it out and start working on it. Okay, especially after tomorrow, and you'll really know what kind of stuff you need to work on. Then next week, we'll kind of see where we're at, okay, in terms of projectiles, but I don't have a lot of plans to spend much more time, okay, on that stuff, except maybe one day, but then that takes us right up to the exam. Okay, so because we have that short week, right? Okay, you guys have the extra long weekend. Coming up here. All right. So just make sure that you are taking some time over the weekend to start preparing for your test. Don't leave it till next week, or you'll find yourself behind the 8 ball. Okay. So what I want you guys working on here is just a few of the projectile motion questions from the workbook. I will tell you which ones, and then we'll spend some time looking at kind of what exceptions each one has. Okay, things like that, just so that we are familiar with the pattern, okay, and the way things are going to be asked, so that we're ready for them for the unit exam. So, okay, so I would like you guys right now to be working on, from your digital workbook, this is the bottom of page 9 and page 10. I would like you working on five, 6, 7, and 10. 5, 6, 7, and 10. Yep. Okay, so here's the thing with number 10. We're talking about maximum height. And I told you in class there's 2 ways you can calculate maximum height in a projectile motion problem. The way I recommend, which from walking around looking at everyone's sheets is not the way most of you did it, okay? And the longer way that most people screw up, which was why there was so much weeping and gnashing of teeth in here, okay, over the last like 10 minutes or so. Okay, so let's have a look at this one. We've got 20 meters per second, 27 degrees above the horizontal, okay, and we are dealing with a projectile arc, but they are asking us about this point right here. What's the vertical displacement at that point, or the maximum height, okay? So we're looking for that value. What do I have to remember about the speed, vertical velocity, let's say, of the object at this point? It's 0. Okay, so our other givens go like this. I don't need any horizontal information for this question. Okay, there's no point in spending any time calculating any horizontal part of this because it's not necessary. Okay, so the short way to do this is to simply use this formula here. Vf squared equals Vi squared plus 2AD. Here's why this is shorter. What's not required for that formula? T. Calculating T is an additional calculation. If I don't calculate T, I have less work and less chance to mess it up. Okay, so A equals negative 9.81 meters per second squared. I have to calculate VI vertical. That's this side of the triangle right here. So that'll be the sine of 27 times 20, which is going to be like around 9.1 or something like that. Okay, so sine of 27 times 20. So 9.07, 9.08. Okay, meters per second, and that's up. Right? And we're saying that at the maximum height, VF is 0 meters per second. So I've done one calculation, and now I have enough information to solve for maximum height. Right? All I have to do is manipulate this formula here for D. So D will equal VF squared minus BI squared over 2A. So 0 squared minus 9.08 squared divided by 2 times negative 9.81. All right, so 0 minus this number here squared divided by negative 19.62. That's 2 times negative 9.81. All right, 4.2 meters. Okay, so I only had to do 2 calculations to solve for D. Now, is there another way to do this? Yes. Is it legitimate to do it that way? Yes. Is it more work? Yes. Okay, why is it more work? Because in order to solve for it, I have to use this formula. And that formula requires something I don't have yet, time. Now, there's 2 ways to get the time here. One way is less work than the other. What I saw a lot of people do is this. A equals VF minus VI over T, and then they went negative 9.08 minus 9.08 over negative 9.81 to get the time. That's the time for the whole flight. Then they had to divide that number by 2. When they could have just done this. Would that give me the time for half of the flight? That's all the time I need. And then I wouldn't have had to remember that I have to divide that number by 2 when I put it in here, which is the mistake people make when they use that formula. Okay? It is perfectly fine to use that formula, but I don't recommend it. Because people mess it up way more often than the other one. The problem is, that's the formula everybody remembers because we use it more often. People forget about this formula because really the only time we ever use it is for maximum height in a projectile question. Right? So I'm just saying it's fine to do it either way, but let's say next week maybe you have a unit exam and time's a factor. Doing it the short way makes a lot more sense. Okay? Just saying. Okay. So is that one making sense? It's the maximum height part that usually gets people. Okay? Like people do fine on the horizontal distance and the projected horizontally questions. It's always the maximum height that snags people. On your exam next week, there's going to be one of each type of projectile question. You're going to have one projected horizontally. You're going to have one projected at an angle. All right? And I am going to ask you for both the horizontal distance and the maximum height in the projected at an angle question. Okay, so very much like most of the projectile questions we've done thus far. Okay, so expect to see some like that. Are there some more on this worksheet like that? Okay, not a bad idea to probably have a look at some of those, I would say. Okay, now this one is a little bit different because it's asking you for something a projectile motion question doesn't usually ask for. It usually gives you this. It wants to know the projected velocity. It does tell you the angle, which makes your life a little bit easier, okay? But it's wanting the projected or launch velocity. All right, see if you can figure that one out. So the question wants us to calculate the projected velocity, which, like, we know that the object's going to do this, and we know that the maximum height is 5.75 meters, okay, we know that at that 5.75 meters, the vertical velocity is 0 meters per second, okay? And if I want to get this side of this triangle, I need either the horizontal velocity or the initial vertical. I need one or the other because I already have an angle. If I have an angle and a side, I can figure out everything else. Okay? So I need one more side. And there's no way I can get that horizontal side. I don't have enough information to do it. Okay? But can I find VI? I can, because I have this formula here. I know VF. I'm looking for this. I know acceleration, and I know the displacement. Okay? This question, the purpose of having this question on there is to force you to use that equation. There isn't any other way to do it. Okay? You have to use this equation. It's the only one you have enough information to use. So if I'm looking for VI, I'm going to subtract VI over to the other side. Okay? Or actually, I'm going to subtract 2AD over to the other side and leave VI here. Okay? So VF squared minus 2AD equals VI squared. So I would need to square root all of that to get VI. So I'll have the square root of 0 squared minus 2 times negative 9.81 times 5.75. All right? When I plug that in, okay, I get 10.62 meters per second. That is not my answer. It is this side. And now that I have that side, I can find the hypotenuse of that triangle using sine. Okay, I can say that the hypotenuse, which is what I'm looking for, is the opposite side, 10.62, divided by the sine of 30 degrees, which is why it comes out to 21.2 meters per second. That is my projected velocity. Okay. In the end, is there a whole lot of work to do in that question? There's like 2 calculations there. Okay? Those kind of questions tell me how well you understand projectile motion versus how well you can memorize a pattern. This one doesn't have a pattern. Okay? It's not like some of the other ones we've done where, okay, first I find this, and then I find that, and then I can do this, and then I can do that. No, this one makes you understand and draw on that understanding to arrive at the answer. All right? Everybody with me there? We did one like that yesterday. That was the spoiler. Okay, that one's actually pretty quick. You should be able to do that pretty quickly. All right, guys, let's have a look at this one here. So the object is thrown from the ground into the air, okay, at 15.7 meters per second. The angle is unknown, but they do give me one really useful piece of information, time, which I can use with either the vertical or the horizontal parts. Now, if all I need to do is find this angle, and I already have a side, what else do I need? I only need one more side, right? Either the horizontal or the vertical will do. Well, since I know the time is 2.15 seconds, and I know that it travels horizontally 25.0 meters, I would say finding the horizontal velocity would be the quickest way to solve this question, right? V equals d over t, 25 over 2.15 will give me this side here. Okay, so now that's 11.63 meters per second. Now that I know that, I just do a trig function here. I use cosine to get my angle, right? So I'll say that the I'll say theta equals the inverse cos of adjacent, 11.63, over hypotenuse, 15.7, right? I do that and I should get 42.2 degrees. Okay? So for tomorrow, listen in here, guys. Okay, tomorrow is our unit exam review, so if you have questions, okay, tomorrow is a good day to ask them since we'll be going over what's on the test, okay, and I'll take questions from you guys when I'm done talking about that. So if you have something you need to ask, tomorrow is a good day to do it. All right, remember to have your vector assignments done for tomorrow as well, please.